This tutorial is going to talk about section 11.2, surface areas of prisms and cylinders. And the first thing that we're going to do is dissect every part of a prism. So let me put one up here for you. Alright, so here's an example of a prism, but what exactly is a prism? And a prism is a polyhedron with exactly two congruent parallel bases. So in this figure, the bases would be this top piece and this bottom piece, because they are congruent figures and they're parallel. They're never going to intersect each other. So we can go ahead and label those as bases. There's one there, and there's one here. All right. So what are the other sides called? Well, the other sides have a special name too, which are lateral faces. So we have three lateral faces in this prism. We have this one in the back, this one in the front, and then this one that goes all the way around to this side. So there are three lateral faces in this figure. Alrighty, so what else are there? There are also lateral edges, and those are the edges that actually connect the lateral faces together. So for example, this right here connects that back face with the front face. And this one here connects the two back lateral faces. And then I have this one here. So these are lateral edges. Okay. We also have height of prisms as well. And the height of a prism is always a perpendicular height, just like what we've learned this entire year. If I'm talking about the height of a figure, it has to be a perpendicular height. Okay? So when you're looking at these, make sure that you see that right angle before you assume that it is a height. Alrighty. So now we have two things to talk about in terms of area. We have what's called lateral area and something else called surface area. When we do lateral area, it is only considering the area of the lateral faces, not the bases, just the faces, okay? Area of the lateral faces, okay? It's kind of like a way to remember this is the labels on a can, like a can of corn or a can of beans or whatever that you find at the grocery store. If you think about where the label goes, it just goes on the lateral part. So labels of a can. So that's the lateral area. The surface area is the area of the lateral faces plus the bases as well. And the best way to remember surface area versus lateral area is surface area would be like you're wrapping a gift. Think of where the wrapping paper goes. It goes on all sides of that gift. So that's what surface area is like. And are there formulas for these? Absolutely. So let's take a look at the formula for the lateral area of a prism. And the formula is, I would say, S lateral. So the S is for surface area, so surface of the lateral area. And the formula is capital P H. And the capital P here is not just the perimeter of the figure. I mean, that seems like it would be hard to do. This capital P is the perimeter of the base and the height. So the capital P is the perimeter of just one of the bases, not two of them, and then H is for the height of the figure. And remember that the height has to be a perpendicular height. So then surface area now has a formula as well, which I would denounce as S and then total. That means including the bases and everything. So I'm going to take the lateral area like before, and I'm going to add that to 2 times capital B. And the capital B here part What does that stand for? Well, it's the area of the base. Oop, that's kind of hard to read. Let me fix that up a little bit. Area of base. And since there are going to be two bases, that's why the 2 is there. Okay, so now that we know all this, let's see if we can apply it. Let's check out a couple examples. Okay, so in this example, my prism is over here, and we have bases that are pentagons, and all of my lateral sides are rectangles. And let's put some numbers on this figure so we have something to work with. Alrighty, so here we go, and these are going to be in inches. So we're going to go through the process of finding the lateral area, and then we're going to go through the process of finding the surface area. So the lateral area, first of all, is going to be capital P. Well, what does capital P stand for again? And that means it's the perimeter of a base, okay? So just pick a base to work with. I will work with the top one, I guess. So this one here. And we want to figure out its perimeter. Well, since that figure is congruent to this one down here, all of the sides are going to be 4. So this is 4, and so on and so forth. So 5 sides times 4 is going to be 20. So I'm going to write that in here. And then I need the height. And the height is a perpendicular height. So it would be literally this guy right here, because there would be a right angle there if I was looking at that straight on. So the height is going to be 6. And then we can calculate that. Let's see, 20 times 6 is going to be 120. And since this is an area, we need our units to be squared. So there we go. So then what about the total surface area? So I'm going to take what I just had, that 120, and I'm going to substitute this pH part with 120 because that's what I just solved for. And let's see, what does capital B stand for again? And that would be the area of the base. So we have to find the area of a pentagon. And remember that if we need to find the area of any regular figure, we need an apothem. So if you look at the top figure here, I went ahead and plugged one in. So my apothem connects the center of that figure to a side at a right angle. And this is going to have a length of 1.5. So the formula for the area of a regular polygon is 1/2 times the apothem times the perimeter of the figure. So let's go ahead and plug in what we know. So the 1/2 is going to stay there. The apothem is 1.5, so I'm going to write 1.5 here. And then the perimeter of that figure was 20. So I'm going to go ahead and calculate this inside part. And that gives me 15. So now I have 120 plus 30, because 2 times 15 is 30, to give me 150 square inches for my surface area. So that's how we do those. And the last one that we're going to talk about is how to find the areas of a cylinder. Okay, so we want to get our formulas written to find the lateral, or like the label side of a can, of a cylinder. We are going to follow this formula here. It's going to be 2 pi r h. So this part right here is circumference. So we're going to take the circumference of our figure and multiply it by the height. If you want to look at this in a more simplified version, we could do twice the radius, because that's 2r, and that would give us diameter. So another way of looking at this is pi dh. So pi times the diameter times h. It really doesn't matter which one that you use. All right, so then how do I go about finding the total surface area? Well, it's going to be the same exact thing. I'm going to do that 2 pi rh business, and then I have to add twice the area of the bases, which we know to find the area of a circle is pi r squared. And if we forgot that, let's go ahead and write this up. So area of a circle equals pi r squared. All right, so let's look at an example. Okay, so let's go ahead and go through the process of finding the areas here. So we'll do the lateral area first. So that's 2 times pi times the radius, which in this figure is 4 centimeters, times the height, which is always a perpendicular height, which is 10. So if we want to, I think it would be a lot nicer to leave this answer in terms of pi, otherwise we're going to have a decimal. If you do decide to multiply the decimal out, make sure that you leave it at 3 decimal places. So 2 times 4 is 4, or I'm sorry, 2 times 4 is 8, and then 8 times 10 is 80. So my answer here is 80 pi centimeters squared. That's me leaving that in terms of pi. So then now we're going to go through and find the total surface area. So I'm going to take that 80 and I'm going to add that to 2 times the area of the base. So the area of the base is pi times r, which is 4, and then squared. So now I have 80 plus 2 times, let's see, 4 squared is 16, so that's 16 pi. Let me start over here. I think I'm running out a little bit of room. So now I have 80, oh, and I forgot the pi in there. I'm so sorry. I was wondering what was going on. So 80 pi plus 2 times 16, which is 32 pi. And then I add the pi's together. So 80 plus 32 is going to be 112 pi centimeters squared. And there are your 2 answers. And that concludes this tutorial.